All right, guys. So just kind of reviewing our rules up here. I want you guys to go through this without looking at your notes. Look up here. Tell me, what is the derivative of a constant?
0.
0. What is the derivative of kx? K, right. What is the derivative of kx to the n? Now raise your hand for this one. I need just one person. Let's go with Jared Steiger. All right, very good. So what we have to do then is multiply the coefficient times the exponent. That becomes the new coefficient. X stays x, we subtract 1 from the exponent. All right, do you remember this one? Let's go with you, Chase. What's the derivative there?
K.
All right. And then what about the derivative of k cosine? Jared?
Negative K.
All right, so those were the derivatives we learned about. So now let's come down here to Friday's notes. It says if y equals 2 over 3x squared, we're going to go through these steps. First, we're going to do a rewrite. In order to be able to take a derivative, we have to have it in this kx to the n form. If you notice down here, this is not in kx to the n form. Can someone tell me how to rewrite it?
6.
Nope, just to rewrite.
2/3.
2/3, yes.
X to the negative 2.
Very good, Dominic. That's correct. All right, so we have our rewrite. So now we are ready to take the derivative. So we have to do k times n. So we have to do 2/3 times negative 2. That's negative 4/3 x. Now we have to subtract 1. So negative 2 minus 1 is negative 3. This is our answer for our derivative, but we need to simplify our answer. So it's negative 4. To make this a positive exponent, it's going to have to go to the bottom, and then it would become a positive exponent. And that's going to be our simplified derivative. In your book, they're going to give you these. They're going to tell you to do a rewrite, differentiate, simplify. They're just trying to walk you through the steps. I think they even have a chart that says rewrite, derivative, simplify. You don't have to create that chart. Just do the process. All right, one that's a little more challenging. This is pi over, we have to square the 4 and square the x. So that's going to be 16x squared. Remember, we're not allowed to have negative exponents on the x. So I have to recreate this as pi over 16x to the negative 2. Because now it's in that kx to the n form that we need. So Jacob, what is pi over 16 times negative 2? Right? So it's negative 2 pi over 16x. Brittany, what do we get if we subtract 1 from negative 2? Good. So now I'm going to simplify this a little bit. 2 over 16 can reduce to negative pi over 8. And now the last thing I have to do is get rid of that negative exponent. So it's pi over 8, negative pi over 8, x to the third. We only have to worry about negatives if they're exponents, not if they're coefficients. All right, flip over to the back. All right, now notice this problem. This is not in kx to the n form. This would just have to be an x. It's not allowed to be an x plus 3. It has to just be an x. So when we run across something like this, we have to completely multiply it out. So this is going to be 4. Does anyone know what the quantity of x plus 3 squared is? Perfect. So there's still just our original function. We need to distribute through the 4. Just distributing out the 4. And now we're just going to take the derivative of each term. So the derivative of 4x squared is 8x. The derivative of 24x is 24. We're trying to find the specific slope now of the tangent line to this at 2. So what do I do with the 2? Plug it into this derivative. So f prime rather of 2 is 8 times 2 plus 24. That's 16 plus 24, which is 40. Some of you are going to go to colleges where your calculus class is mainly involving using the calculator. Others of you will go to schools where you're not even allowed to use the graphing calculator for calculus at all. I'm not saying one is easier and one is harder. It's just going to be different types of problems that you're going to deal with. If I'm in a class where I'm taking a test and I'm allowed to use my calculator, I'm going to check this answer. So I put in my function. I can do a zoom 6. Here's the function. I want to find the slope. So I go to second trace, and if I go down here to number 6, to dy dx, and now I push the number 2, it's going to tell me that the slope at 2 is 40. Okay? So if you know these kind of things, you can check your answer. No matter where you go to college, they're going to expect to see all this work, but at least if this doesn't match that, you can go back and find your mistake. Okay? Let's look at example 4. Again, we have to have kx to the n for every term. This is not simplified at all. See, each one of these is over top of x. It's just like if I asked you what's 1 plus 2 plus 3 over 6. What is 1 plus 2 plus 3? 6 over 6 is 1. So I could have written this as 1 over 6 plus 2 over 6 plus 3 over 6. Wouldn't that still give us 1? So that's what we're going to do on this one. We have to put this term over x, that term over x, and that one. So we're going to have h of x equals 2x squared over x minus 3x over x plus 1 over x. I'm going to simplify that before I take the derivative. 2x squared over x is 2x. Negative 3x over x is negative 3. What's another name for 1 over x? X to the negative 1. Now each of these are in kx to the n, like I need. So the derivative of my first term is 2. This is 0. This is going to be 1 times negative 1, which is negative 1, x. Subtract 1, we get negative 2. So that's going to give us that answer for our derivative. But look at what the question's asking. Find the slope of the tangent line to this curve at x equals negative 2. So now we would have to plug in negative 2. So we're going to have 2 minus 1 over negative 2 squared. That's 2 minus 1/4. What is 2 minus 1/4? 7/4 or 1 and 3/4, whichever way you want to write it. Let's do a quick check. It never fails that when we, sometimes people check a problem like this, and a person will always come up and say, that's not what my calculator said the answer should be. If it's not, it could be that you're not typing the problem in right. If I type this in, I have to have the whole entire numerator divided by x. A lot of times people forget the parentheses, and then they don't have it typed in right. So now I'm going to graph it. I go to second trace. I go down to my dy dx, which is number 6. I put in negative 2, and it tells me it's 1.74999. Does that support the fact that we got 1 and 3/4? Which answer is better, 1.74999 or 1 and 3/4? 1 and 3/4 is the exact slope. The calculator can't use calculus to find the slope. It's literally trying to measure the pixels. It's not going to be able to be exact. This is just to support our answer. All right, so the last thing we want to be able to do is to find the equation of the tangent line. So to find the equation of a line, what are the two things we need to know? Slope, what else? Y-intercept's helpful, but could we also do it with a point? Yeah. So I need to find the slope, and how do we find the slope? By finding the derivative. Now they've given us the x-coordinate for our point, but we would also need to know the y-coordinate. How do I find it? Plug it in. So y is going to be -1 to the third plus -1 minus 2. So that's going to be -1 minus 1 minus 2. That's -4. So now I'm ready to find the slope by finding the derivative. So the derivative of x to the third is 3x squared. The derivative of x is 1. The derivative of -2 is 0. So now I have to find y prime of -1. So I'm going to plug in -1 into my slope. What do we get? What is it, guys? 4. So 4 is our slope. So once I know my slope is 4 and my point is here, I can now use point slope, which is y minus y sub 1 equals m times x minus x sub 1. I sub in here, here, and here. So y minus y sub 1 is -4 equals my slope times x minus -1. So I'm going to have y plus 4 equals 4 times x. That would be a big plus. So plus 4. So my final answer then is going to be y equals 4. Oops, why did I make that a 4? I got ahead of myself there. So I'm going to have y equals 4x plus 4, and then I have to bring over the other 4, so it's just y equals 4x. Okay, what questions do you have? Any questions about how we did that? So our goal here was to be able to expand our knowledge of derivatives as well as being able to find the equation of the line. Guys, watch if I can check this even real quick. Let's go under y equals x to the third plus x minus 2, and then into y sub 2 I'm going to put in this tangent line of 4x. So now when I graph this, it should appear that this is a tangent line, this line y equals 4x. I can look at my table and they should have that point -1, -4 in common, and they do. And so that tells me that it's tangent right there. It's kind of hard to see it unless I zoom in a little more. But I think if I zoom in, you'll be able to tell that it's tangent. Here's our curve. Here comes the line, and we can see that it is going to be tangent right there at -1, -4. Questions? All right, very good. You have your assignment on your assignment sheet. Still have about 15 minutes. You go ahead and get a good start. I'm also going to